That didn't sound so good.
For us, it's not bad. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Dan Maloney.
This is episode 346, melting metal in the microwave, unlocking car brakes and washing machines, and a series of tubes. Too much Hackaday news this week. I want to start off with congratulations to the 2025 Component Abuse Challenge winners. This one was super fun. Our judges worked super hard on it. $350 DigiKey certificate winners were Miroslav's Hankar's LED candles, which was awesome. He lights. I actually had to make an animated GIF for the write-up on this one because it's so awesome. He takes a lighter to an LED and senses the change in the forward voltage drop when it heats up and uses that to light the LED. It's an awesome special effect, but then in some of them you can see he holds the fire on there too long and it actually smokes a little bit.
Literal abuse of components.
Beautiful. Another one we actually featured on the podcast last week, I think. Jenny picked it. Luke Barker's electrical slip ring. He basically cheats and uses a phono jack as a slip ring. Fantastic. It turns nicely. The contacts are meant to take a lot of abuse. Great idea, at least for a kid's toy here, which he's using it for. And bringing up the rear, one we also covered maybe 4 weeks ago, Craig D's boosting voltage with a cable, where he sends a pulse down a length of coax and then times the next pulse to match exactly when it reflects back to the source. And he just keeps doing this over and over and over again. What does he get? He gets something like 140 to 200 volts off of a 15-volt power supply with no inductors, no capacitors, just sending electromagnetism down a wire and bouncing it back off. Really, really fun. If you want to check out all the entries and our honorable mentions, read the article on Hackaday. Congratulations, 2025 Component Abuse Challenge winners. This week in crazy math, the Rupert property has a counterexample. If you don't know the Rupert property, I didn't either. Mathematicians are fun. The idea is that if you take any polyhedron, there's some kind of angle that you can rotate it to that will make it be able to pass through itself. And this is a conjecture from the 1600s, actually. Prince Rupert's conjecture. You can think of it like, if you had a cube sitting on your desk, there's some way you can rotate that cube so that its shadow is smaller than the face of that cube. So, you can rotate it to push it through itself with a little bit of wiggle room. The astute of you out there will say, well, what about a sphere? And that's the one shape that doesn't work. The asterisk here is that the shape has to be a polyhedron. And you can think of it because, you can always kind of angle it just right so that it's a little bit smaller. Except now a counterexample has been thought up, and you will not be surprised. It's a polyhedron that's not quite regular, and it kind of almost looks like a sphere. But it's a counterexample to a now 400-year-old mathematical conjecture. So how cool is that? Plus, it's called the Nopert hedron, for Nope and Rupert put together. And hedron because it's a polyhedron.
Oh, mathematicians.
The Nopert hedron. And last up, Internet Archive hits 1 trillion web pages. Hackaday's been around for 21 years, and a whole bunch of our early hacks kind of get so old that they fall off the internet. And slowly but surely, we'll have readers notice this and let us know, and we'll go in and fix the links to point back to the Internet Archive / Wayback Machine's original archiving of the pieces. And for our purposes, not losing hacker research and information, Internet Archive is absolutely astoundingly useful. 1 trillion is a very big number of web pages. And Hackaday is proud to be crawled by them since very long ago. So the good news is most of our stuff is kind of backed up on Internet Archive. It's the memory of our global hive mind.
This is a journey into sound.
What's that sound?
What's that sound?
And that's it for news. So let's do a What's That Sound?
Roger that.
This week is a reveal week. Last week I played a brand new sound. 12 people got it right. Let's see if Dan Maloney can be lucky number 13.
Wave file. There it is. Oh, that's an elevator.
Yeah, exactly.
Elevator door closing and then beep, beep, beep up the... Actually, that's the most annoying buzzer sound. An
Thank
elevator,
you.
Isn't it? I like the nice ding, ding, little
Thank
soft
you.
something, but...
So of our 12 responses, I think basically everyone was like, it's a freight elevator making that horrible buzzing noise every time it goes by a different stair. No, this is the elevator in the Courtyard Marriott. This is a guest
I
elevator.
swear I've heard it before.
This is the elevator
yeah.
I had to take up and down the stairs, getting buzzed at like that, bright
The
and
one in
early in the morning.
Pasadena. Yeah, right. Yeah.
That was so horrible. I finally decided I'd record it and publicly shame them.
Well done.
Everybody who guessed freight elevator going up and down, you're so close to right. I counted it. You know, it definitely should go bing instead of going wah. It's absolutely terrifying.
All elevators are freight elevators if you consider humans freight. So
This is true. Elevator man guessed it's an elevator, judging by the passing tone, probably an Otis. Appreciate that. The specifics there. I have no idea. I didn't check. I probably should have. Vintage floor buzzer, Dario describes it as. I think that's being very kind, but I'll take it. A bunch of people also suggested that it was an elevator with the overweight buzzer going on. It's like you loaded too many people into it. But no, that's not an alarm. That's just what it does. 6 times if you're on the 6th floor. All right, anyway, 12 answers correct. The benefits of having a wife who's into D&D is that I have a 12-sided die. Here goes. 5. Congratulations to Andy Geppert, the elevator experience. Oh, what? He says the elevator experience at Green Tree. That's the other hotel that people stay at. I'm giving it to you here.
Okay.
Congratulations, Andy. We'll get in touch with you and get you a Hagaday podcast t-shirt. Maybe their elevator is just as bad.
Maybe it's a California rule or something like that. You have to have an annoying elevator sound.
No, the elevator on the other side of this very hotel goes bing.
Ah.
The elevator I always get assigned to goes meh. I played it for Al because he was also staying in the same hotel, and he's like, what? My elevator goes bing.
The machine that goes ping.
Different. Anyway, congratulations, Andy. I'll get you a t-shirt forthwith. Everyone else, stay tuned next week for a brand new sound and your chance to guess. Well, let's start up the hacks. I wanted to start with a reverse engineering hack. Reverse engineering the Miele diagnostic interface. I think some relatives of Severin's have a 20-year-old Miele washing machine, clothes washing machine, and it had some problems. And so he took it apart to help them fix it. It came down to the pressure sensor that tells how much water is in the drum. So it's actually got an analog pressure sensor that says, I have this much water pushing down on me. The drum is or isn't emptying. Throw an error code. And so replacing that is easy. It needs to be calibrated, however, because it needs to know, how much water is too much and how much water isn't. How do you calibrate the pressure sensor in firmware on a 20-year-old washing machine? And this is a really neat write-up of kind of his reverse engineering efforts on this machine sparked by this problem. I thought it was equally cool. The correct way to do this is you get the official diagnostic tool, and one of the LEDs on the front panel is actually got a photo detector in back of it as well, and it uses the IRDA protocol to blink data across. You hold this diagnostic tool up to it, and it blinks back at it. So it's got a two-way, kind of serial data communication through IRDA hidden in one of the LEDs on the front. It was like one of the empty the washing machine or the pump's running light or something like that does double duty as this debug standard. I think that's fantastic. The keywords to look into this are Mila diagnostic utility and Mila optical interface. But again, it ends up just being IRDA, which you'd think. So Severin wants to hack this protocol, of course. So he buys a board on eBay and starts working on it. First thing you can do is desolder the EEPROM and dump that, see what it's got. It unfortunately only has some kind of boring stuff in it, like the whether you have hard water and the region code and some other cool stuff to look at, but nothing that tells him how this communication protocol works. The CPU is a mask ROM and it's not reading its program memory from anywhere, and you probably can't dump it without being able to glitch the chip. So that's kind of a dead end. What do you do? And one answer is that you can just take an LED and a photo detector and try to blink at it. And so he gets a whole bunch of data sheets, and it looks like an immense amount of research went into attacking this machine. What he ends up doing is taking a Mila protocol from a related family of machines and try kind of brute forcing codes in the line of what they do to get into it. And unfortunately, that also fails for whatever reason. So then he has to dig one level deeper, and he's looking at the MCU's data sheet, and he finds that it has a sync signal that it holds high and drops when it's fetching information. It's like a 6502 kind of CPU, and when it's fetching commands, it raises this line, and when it's done running them, it lowers this line. And this is one of those things that you'd think they would, get rid of this line in production units. It's totally useful for debugging, but probably not necessary in production. It's still there. So to start talking to this machine, he has to send it the right code, basically, the right initialization startup code. How do you know what the startup code is? Well, you figure that the machine has an if-then statement in it where it's like, if I see the code right, then do this one thing. If the code's wrong, do this other thing. The basis of the attack then is that it'll take a different amount of time to run the code, whether you've gotten the passcode right or whether you've gotten the passcode wrong. And because he can see the sync line, he can tell how long it is operating in this section of the code. And so he actually just goes and brute forces it over the space of, I can't remember, it's like a 5-byte code, 5-byte sequence or something like that. So he builds a little LED and photoresistor unit, tapes it to the front of the machine so that he can blink at it, and he just brute forces it. He just runs all these codes and watches how long the sync line is raised. And believe it or not, one of them is different. And that ends up being the correct passcode. And once he's got this, he can do essentially everything with it. It gives him full access to the chip. So for instance, he can dump the firmware. And that he did. It took about 30 minutes to blink the firmware out over this little service LED, but he managed to get it out. And that's where this story ends. But if you love reverse engineering stories, this one has all of the wrong turns and dead ends in it. I kind of breezed over a lot of it. This one reads like a whodunit novel. You should really go check out his page. But what I just loved here is that it ends up being this kind of same low-level attack that people do on getting through password checks or getting through bad encryption algorithms. This kind of timing attack where you can see how long it takes when you do it one way versus another, and then you overlay a brute force over that applied to a washing machine control board from 20 years ago.
I am just so taken by that IRDA interface. If I had a broken washing machine and I was on Reddit or someplace and trying to get information about how to fix it, and they said, oh yeah, well, you get this diagnostic information, all you gotta do is hold this magic wand up in front of it and it flashes the LEDs. And I'd be like, nah, come on.
Right?
You're making that up. But then, you look at the PC board, there's two LEDs right next to each other. One, got like a bezel in front of it. So you don't really see either one of the LEDs. I mean, I've certainly seen diagnostic limited diagnostic, blink an LED in a certain pattern and it means a certain thing.
Right.
Seen that, back to we recently did an article on a old arcade machine, Defender. The main board actually did that and it blinked, a number of times for different errors. So it had a code that it would show you, so I'm used to that. But this is way more data rich than that. If you can dump an EEPROM over it, it's next level. And hats off to the Mila engineers for coming up with something like that. And again, I would have just laughed at you if you told me that's what they were using for a diagnostic output. I'd look around for a jack or something like that, or like a JTAG connector on the main board, something like that. I would never expect that at all.
Yeah, the idea that you can just, like you said, hold up a magic wand to it and blink the codes at it is so fantastic. I think that's really sweet. And the fact that it's kind of like almost hidden in plain sight is really cool too. Very, very fun, but also just an absolutely brilliant hack here. So give it a look. Ticks all my boxes.
This kind of feeds into my first pick, Hyundai Paywall's brake pad changes. And this one comes via a Reddit post. A Reddit user or Redditor was a Soltronic Pair who had the experience of wanting to do some DIY work on Hyundai Ioniq, which I believe is an electric vehicle, with electronic parking brakes, no matter whether it's an EV or not, which have become increasingly prevalent in cars. You've got to actually unlock the brake pads. You have to pull them back, and that requires a bidirectional scan tool. Normally, that's not a problem. Normally, you could just go get your bidirectional scan tool, which aren't terribly expensive, and just run the command that backs the brake pads off, and then you go ahead and do probably the one repair that's left to the average home gamer. You hear I open the hood and I don't even know where to start, blah, blah, blah. And that's true to some extent, but the brakes are right there on the outside of the car. They're a super simple, mechanical system, a hydraulic system. Usually you don't have to do any kind of interfacing at all, except for in the case of electronic parking brakes where you have to back them off, and you can do that. Well, Hyundai says, nah, you're not going to do that anymore. And if you follow the story, it's really not Hyundai that's got this problem. It's an outfit called the National Automotive Service Task Force, which has decided that you need to be a member of this organization, in possession of a $2,000 interface tool, paying $60 a week in subscription fees in order to be authorized to run the software that backs off these brake pads. Really, really unfriendly to the DIYer. I understand that there's security issues with a modern car. You don't want someone necessarily walking up to your car with a scan tool that can unlock their car. Certainly don't want that. Some argument to be made for restricting access to at least certain functions of interfacing with a car. But brake pads? Come on, guys. That's like the one thing left that we had to work on, and now they want to take it away. And I think, I could go on a rant here because this is like a hot button topic for me. I will keep pushing back on car manufacturers, when they're making cars quote unquote too complex to service. I'll be like, nah, I'm gonna try anyways. But when you run up against something like this, where the software won't even run unless you have a sign in with an ID for this outfit, it's not really right to repair violation or anything like that, but it still pushes the line a little bit too far for my comfort. And I certainly wouldn't want to purchase a car, then find out afterwards I was not able to do something as simple as brake changes. It would bother me immensely. But there's a happy ending to this story. Apparently the user was able to get a hold of a trusty Harbor Freight T7 scan tool, which is only $3.99. It's actually the scan tool that I'm looking at buying right now. And was able to back off the pads using the bidirectional features there, although there was some sort of warning dialogue that popped up, but it did the electromechanical thing anyways and backed the pads off, and the brake job could proceed. So, happy ending to the story. It didn't take much quote unquote hacking, but at some point I would expect cars like these, you could probably see people diving into the CAN bus and trying to figure out how to get around the software restrictions that prevent you from doing simple things like brake pad changes. If they're doing it to brake pad changes, they're doing it in other places in the car. There's definitely other things in these cars that are going to be locked out. This national task force thing certainly looks like they would take the opportunity to extend that reach into other parts of the car to protect the ability of kind of job security for mechanics, which I get, which is certainly a concern, but saying just an outright no to DIYers to me really rankles me and rubs me the wrong way.
Even if it is, a mechanic, your poor mechanic is held
Yeah.
hostage by this like $2,000 tool with a subscription fee. I mean, it's, yeah. You said it isn't right to repair. It's not like against the right to repair laws because they are all written as if it was the manufacturer doing it, not some sketchy association doing it. But, whatever, same effect. It seems really crappy to me. I'm glad that I don't have to suffer this. But I guess there are a lot more cars these days that are harder and harder to repair yourself. But my God, like you say, changing the brake pads should be a no-brainer. Well, on a less controversial note, we have Martin Pitterman, the simplest ultrasound sensor module minus the module. I love this one. This is his own take on doing a kind of completely ground up, significantly improved version of like those SR04 ultrasonic sensor modules, right? And if you've done any projects with them, you know that they are both really awesome, really cheap, and a source of frustration. One of the real problems with them is that they can only do fairly close detection of reflected objects, and they only detect the first reflected object, and it kind of has to be pretty much in the center, and sometimes they have weird reflections. So you might want to start hacking on it and put some more brains in there. That's what Martin says. He says, I'm going to build my own to solve the first problem, that is that the echo returns are often very quiet. He looks to other modern devices that do the same thing, namely radar. And what radar units do these days is frequency modulated continuous wave, which is to say they send a sweeping up chirp of a signal out, and then when they receive it back, they mix it together with the next chirp that they were going to send. So they send out regular chirps all the time. They get the reflected chirps back. Because it's doing a frequency ramp, the frequency is going up in time. They use a mixer to combine the signals together, and what they get is the difference frequency between them. You can think about the chirp going out, hitting the thing, and coming back. So there's a time delay there. When you offset these two ramps on each other, the time delay turns into a difference in frequency between the outgoing signal and the incoming signal. And that stays basically constant across the chirp. Gives you a really nice signal coming out of it because you get a really nice long estimate of what this difference frequency is. So that's what he's doing here. He's doing smart DSP version of an ultrasonic rangefinder, and it's absolutely fantastic. He gets a really great result, and he pushes it one step further to where he can detect not just the one frequency difference coming back, but multiples. And so if you imagine you have 3 different objects in the room placed different distances from the ultrasonic sensor, he can actually get the frequency that corresponds to the distance to the first one, the second one, and the third one, and resolve them all. So not only does he get an ultrasonic rangefinder, he gets it's kind of broadly like a radar. He can tell where the different objects that he's pinging are in depth. And that's really cool too. I just love ultrasonic rangefinding because it's simple enough these days that you can do this kind of hardcore DSP to do some fancy stuff with it, even on a simple microcontroller. And here I think he's using the RP2040 to do the math. This is a great dive into what you could do if you had an ultrasonic sensor and wanted to spend a little bit of time thinking about the DSP. And I think that this could become useful for a whole bunch of hacker projects.
Yeah, as soon as I read this one, I saw the FMCW, and it made me think of a post I wrote some time ago by a fellow named Marshall Bruner, who has this excellent series on radar everything. Mostly, it seems to be mostly centered around vehicle radars, millimeter wave radars, and things like that. The whole idea is, the basic idea is the whole concepts of radar, and I only really understood FMCW once I saw his animations. It makes it really, really approachable, really easy to understand. If you don't understand FMCW, I'll throw a link in for that article so you can get the concept. Radio or sound, the concept is basically the same. And actually, the first comment in that article that I wrote was, I wonder if it's possible to use those cheap ultrasonic distance measuring modules to do something like this. Well, yeah, it is. And here it is. It's only 2 years later or whatever. So yeah, check that out. It's pretty cool.
Yeah, it's exactly right. And it's just that, right? Like you would think that playing around with radar is hard, but if you change the frequency, if you instead do it with ultrasound, it's dead easy. And I think that's the other thing that strikes me as really cool about this, is that it lets you do that same sort of fancy stuff that you would do with the modern radar, only you're doing it with two $1 ultrasound transducers and a cheap microcontroller. So that's pretty sweet. If you want to look into hacking one of these SRO4 ultrasound sensors yourself, we have a great write-up from quite a while back, 2014. Good Vibrations giving the HC SRO4 a brain transplant. But it's basically a deep dive into how the simplest of the ultrasound sensors works. And if you want to push this the other way into the absurdly complicated, you might want to make a phased array transducer with it and try to do like a radar/sonar sweep of the room so you could get distances to multiple objects across space. And I want to point out BitLooney's awesome video about phased arrays and technology, which is one of my favorite explainers in the last few years. Bend it like a sonar beacon with a phased array. Links in the show notes.
My next pick is casting metal tools with kitchen appliances. It sort of goes against the grain initially when you first hear about it, because Denny is using a microwave to do metal casting. And, what is that you say? Never put metal in the microwave, of course, and we've all done it just to see what happens, and it's a spark show. But his approach, which we've covered a number of times before, and he's worked this method up from the simplest case, melting aluminum, right? That's the one thing that everybody does when they build a gas-powered forge or a charcoal-powered forge or whatever. It's got such a low melting point, and it's kind of an approachable first casting metal. Worked up from that to brass and bronze and copper and a bunch of other stuff, and finally got his forge working well enough to do cast iron, which is usually the metal of kings for the home casting community. Melting down brake drums and rotors and casting them into useful objects is not easy. That's real high temperature stuff, and things can be really dangerous, the casting process. Throw all that away because there's no forge in the traditional sense. There's no gas that's burning. There's no, there's no flame shooting up into the sky and taking sparks with them, which is really cool, by the way. But what's happening in this case, rather, he's got a standard kitchen microwave. I don't even remember the wattage. I think it was like a 1500 watt microwave that he has tilted up on its side so the door opens down, and the whole inside of the oven is standard stock. There's nothing unusual about it, except that he puts this silicon carbide vessel in there. It's made out of silicon carbide, wrapped with like a mineral wool insulating blanket and a lot of Kapton tape to keep it all together. These things are more or less, I wouldn't really say they're disposable, but he does go through them and has to make new ones from time to time. He uses the heat of the microwave to melt the metal in crucibles. It's pretty amazing to see. He just turns the microwave on for half an hour or something like that and opens it up, pops the top off of this vessel that he's got in there, and if it's not glowing white hot, it's amazing. In this case, what he's doing is investment casting. So he's making patterns out of, he's 3D printing patterns out of PLA, putting them into molds made from sand mixed with sodium silicate. So that's water glass. Mix that basically liquid silica, mix it up a little bit to get it damp, makes a mold, tamps it down, all that stuff. melts out the PLA using the microwave, heats up the metal and pours it in. He's got a whole vacuum assist casting tray that he designed to pull the metal down into the mold. He's gotten very good at correctly placing sprues and vent holes so that when he pours the metal, it fills the whole mold and goes where it's supposed to go and doesn't go on his feet. Interesting thing about all of this is he's doing this on the balcony of his apartment. It's like a high-rise apartment somewhere, and his whole balcony is just devoted to these hobbies, these metalworking hobbies. Every time I watch one of his videos, I feel like, don't tell me you can't do something because you don't have the quote-unquote proper workspace for it. No.
Right.
Then he gets it done. Even in this video, he's talking about how I can't really do the cleanup work on this casting right now because it's too late and I don't want to make a lot of noise. So he goes down like to a parking garage and just gets the angle grinder out and does the fettling there. But he does it, and the results are pretty cool.
Yeah, we've been watching his videos since I don't even know when. You said it started off with his metal furnace, but I actually remember him doing glass melting experiments.
Right, the glass.
And it's all the same setup, basically, and he's been kind of perfecting it over I don't even know how many years now, which is, again, like you said, it's a silicon carbide crucible, which when you put it in the microwave gets hot as hell, and then that's in this rock wool insulating container, and then that's all wrapped up and capped on just basically to hold it together. Bunch of gluing stuff together with water glass because that's also temperature compatible. And the rest is just put it in the microwave and let it rip. And I think it's just fantastic how far he's been able to push this kind of simple microwave forge. I mean, melting glass is actually kind of cool too, but then starting to do casting in aluminum and now, my God, cast iron. I mean, it's pretty insane how far you can go. And I think it's just kind of, like you say, he's doing this on his balcony. That's pretty wild and impressive too. But it is just a testament to how far you can push something if you just like keep working on this project and keep improving your techniques. Maybe a year or two ago, he made a video that was kind of the summary of everything I've learned in 10 years of doing microwave crucibling. And that's an absolute treasure trove because he's just going down all of the little details that he's learned. So if you're interested in doing anything like that, you should absolutely give it a check. Here, it's all lost 3D print investment casting, which is super because it's a great way to, every one of you out there who has a design in your mind and a 3D printer can do it yourself in some material or other. I don't think I would jump straight into cast iron.
I'd hate to think that at some point that microwave is finally going to give up the ghost because if I remember correctly, he found that on the sidewalk, someone throwing it out, and it's like does not exist anymore. He'd have to get something else, and maybe it doesn't work as well. Maybe there's some, limitation. Maybe there's some interlock or something like that. I don't think he did any real major modifications to the microwave. So he and that oven have been through a lot together, and I don't I don't want to see it end because I really like watching his videos.
Old Bessie's giving up the magnetron.
At some point, it's going to happen.
All right, last up from me, Pegor K, possibly smallest ESP32 board, uses smallest footprint parts. There's a lot of hedging bets here, but if this isn't the smallest ESP32 dev board, I will eat my hat. This is absolutely tiny. It fits essentially on the size of, the silvery part of a USB-C connector. It is tiny. And he does it by, as the title says, picking all of the smallest parts, and that means it's put together with resistors that are the 01005 size, which are incredibly tiny. And he has a lovely picture that we reproduced in our write-up of one of them. It could fit in the ear of whoever that is, Roosevelt, on the dime. It's the tiniest little resistor. And actually, I saw a bunch of these in person because the final challenge round of the SuperCon SMD soldering challenge involved these. It's just crazy that anyone could do it. I loved how Al, in a last-minute flare of bravado, said, okay, rules for this last round, you can either solder all the other parts as fast as you can, or just go for the 01005. And if anyone is able to get it at all, the first person to get that will win. So you could either try the kind of plausible, humanly solderable parts or just go for the pure gusto. And believe it or not, the guy Marble who won was an 01005 solderer. It is possible to do it by hand, but it's not smart. Pegor here does not hand solder any of this. He's got a heat plate, which is totally the reasonable way to do it. It's still not easy. Don't get me wrong, but absolutely lovely. Why is he trying to make it so small? I have no idea. I think he's just trying to make it so small just to make it so small. I'm old enough that I remember back when all hackers were using through-hole components, right? If you think about the first Arduino Uno board, it had this giant DIP microcontroller on it and a whole bunch of through-hole components soldered into it. And it's just absurd looking by today's standards. I think sometime around 2005, 2010, that zone, most hackers had kind of transitioned to doing things in surface mount parts, or at least half surface mount parts for most of their projects. And we learned, we teched up a little bit. And I'm not afraid to hand solder SOIC parts at all. I actually, by choice now, will do 603s maybe on my boards because it's just easier to pack things into the space and put them together. And this means that I had to learn to do reflow soldering with a hot plate, but that's not that hard either. So I can make better, smaller things now than I could before. And that's really useful. And I think that's true of a lot of the projects we see on Hackaday as well. And I think this kind of slow teching up of all of us in our procedures is a really great thing. It pushes our state of the art forward too. 01005, on the other hand, they're absolutely terrifying. I'm going to go on record as saying I can't yet see the day when populating a board with many of these makes any sense. But I'm sure it will happen. I don't see it yet, but I'm absolutely 100% sure that someday, like, the young hackers will be like, they used to use 0402s? Ha 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 ha, those cavemen, right? Hold on to your hats. Things are going to get smaller, and we're going to get better at it.
I like the first comment in the article that you could fit it into the USB plug itself if you decap the ESP32. Like, all right, challenge accepted.
Yeah, right.
And really, it is by far the largest thing on this build is the USB-C connector that's on the other side of the board, followed by the ESP32 itself, and then that enormous chip antenna. Yeah, there's a extra bit of wire that was needed to help it out. So, I mean, you do have three enormous parts, quote unquote enormous parts. But yeah, if you decap that, or if you could find a smaller package for the ESP32, you could actually mold that into a USB-C connector, and then think about the possibilities for that. That'd be a lot of fun.
We actually saw another neat article this week that you should go check out, Hacking a Pill Camera. Aaron Christoffel is taking apart an endoscope camera. It's got a little ring light and a camera in it, and it transmits out. And it's small enough that you can swallow it. It's got a bar magnet in it, and the company that makes these actually steers it through external magnetic fields. It's a really cool technology. But that's not the point. Aaron Christoffel tears this thing apart and wants to use the camera and just play with it. But it looks gigantic and klotzy in comparison to this smallest ESP32 board. Like, they're using bigger parts. There's a lot more blank space on the PCB. And this is a swallowable camera. And if that doesn't tell you how small this ESP32 dev board is, I don't know what does. It makes a swallowable endoscope camera pill look big and clumsy in comparison.
Well, switching scales completely for my final pick, World War II Secret Agents for Science. This is by Lance Geiger, who you probably better know as the history guy on YouTube. His stories are always absolutely incredible. Really, really good stuff if you're interested in history. And a lot of times he crosses history with technology, as he does in this case. And it's an example of the kinds of specialized teams that were put together during the Second World War to do interesting bits of intelligence. This one centers on the European theater of operations, where it was, as it is in war, in all cases, absolutely critical to have good maps of the area you're working in. This secret mission was to send a team called the Huff Team, which is named after one of the geodeticists that had headed it up. The mission was basically to survey Europe with as much precision as possible. Now, if you're picturing surveyors going out into the battlefields and bravely standing there with their tripods and transits while the shells rain down around them, this rather was a team that sort of followed along behind the advancing Allied forces and captured as much information as they possibly could from existing sources. Think libraries, schools, government office buildings, any place where they would have accurate maps of locations. And of course, cities and towns have a vested interest in accurate surveys because property owners need to know, my property starts here and yours starts there and who owns what. They tend to have very accurate maps of the countryside. If you've got access to good quality maps, if your enemy has already done the job for you, just use it rather than make your own or use the information to augment your own maps. Back then, it was literal boots on the ground, and you had to do the work from scratch. A lot of effort.
Yeah, but sort of cheating. I love that they're, cheating, taking the smart route around and just like, let's see, we've got a lot of maps here. They're very high accuracy. They have no reason to falsify them because they're like property deeds. Let's just borrow these.
We're in Germany. You know what? I bet the Germans make really good maps.
Yeah,
let's go get those.
Who makes good German maps? Yeah, totally. My first quick hack is from Low Tech Magazine. They've been doing a bunch with solar power. This one is damn fine solar powered coffee. You can boil water with solar power, a resistor, and a big solar panel. It just takes a while. Or more accurately, it takes a lot of insulation. And that's kind of the weird version of the story here. As long as you can put more heat into the water than you're taking out of it, it's eventually going to boil. Low Tech has been doing a bunch of cool solar hacks that are similar to this. They're kind of sideways solar hacks. They're making the rest of the system so efficient that you can run it on solar power, doing things that you wouldn't expect. So give them a check if you haven't. It's really fun. It made me think about Danny from Shake the Future's microwave oven doing iron foundry, right? Like it's all about the insulation. Next up, Night Custard Humane Mousetrap lets you know it's caught something. Takes a normal live catch mousetrap, adds a beam break sensor and notification to it. It's pretty simple hack, but it's a great hack. And, a live catch mousetrap is only good if you know that it's caught the mouse and can get the mouse out of there before it has a bad day. I wanted to sneak an OC in here. Tyler August wrote a great piece in praise of plasma TVs. He had a plasma TV in his basement and talks about the technology and the upsides, the downsides. Don't have much more to say about it than that, but it's a lovely read. And finally, Denki Otaku, exploring the performance gains of 4-pin MOSFETs. This is the story of a phantom fourth pin. You all know that MOSFETs have 3 pins, gate, drain, and source, where you put voltage on the gate and the juice flows from drain to source or vice versa. Because the wire bonding and the pins all have a little bit of extra inductance, you can't read the voltage on the source as well as you would like to. The 4th pin on these 4-pin MOSFETs is a basically Kelvin pin. It lets you read the voltage on the source channel through a different path that isn't passing all that current. If you know how 4-wire Kelvin measurements work in other parts of analog electronics, this is the same thing. It's just built into the chip to let you do it. Really cool breakdown of that technology.
First up for me in quick hacks is making a machine to sort 1 million pounds of Lego. I twigged on this one because I saw my son, he came home a couple days ago with the intention of sorting through his Lego bin, which is nowhere near 1 million pounds, but still, he got about 20 minutes in before he just was playing with the Legos. and
That's the liability, isn't it?
That's the problem with Lego sorting manually. This one takes care of the problem with a series of vibrating feeders, conveyors, and a very, very cool vertical bin system, which has 4 bins in 3 columns for a total of 12 bins and a bunch of flaps that determine which bin each piece goes in, uses machine vision, obviously, to determine the pieces on the conveyor belt, and it's showing some promise. There's still a long way to go, but it's definitely showing some promise. Next up for me is the king of rocket photography. Back in the day when I was flying Estes rockets, the dream of owning the Astrocam 110 was always out of reach for the expense, but Bill Engar remembers the ability to actually take pictures at the apogee of your flight. This was a great little 110 camera. If you don't remember that format, it was Eastman Kodak had these tiny little cassettes that you could put in these pocket cameras. They were terrible as far as photographs go, but if you're trying to put it on a rocket, you have some limitations, and these things actually did manage to take a pretty decent photo. They cost $15 at the time. I remembered them being a lot more expensive than that. But then again, $15 in 1979 is about $67 now. So kind of a tough ask for your parents. Last up for me is cheap VHF antenna Can Do. This one is by Australian Ham, Victor Kilo 3 Yankee Echo. He takes basically a tin can and converts it into a magnetic loop antenna that's cut for the VHF band, so he can use it with his handy talkie or something like that. It's basically another episode of Will It Antenna, which he does a lot of, and yes, pretty much everything he has put on this channel has worked out to be a decent antenna with varying values of decency.
All right, that brings us to our can't miss articles. These are long form pieces written by our fantastic Hackaday writing staff. I picked Al Williams' response to the news that the penny is getting discontinued. Hackers can't spend a penny. And what I really liked about this is Al's take on the subject. He looks at the penny not as the currency, but as a small copper disc that you can do fun things with. And so this is kind of his chance to look retrospectively at all the fun hacks you can do with the penny. One of the particular special things about the American penny is that the old ones, pre-1982, were full copper. It was an awesome, cheap, and easy source of copper in a nice form, right? And cheap, right? It only cost a penny. Later, when they switched from solid copper to copper-coated zinc, that gave us another possibility, actually. Copper and zinc makes an awesome battery, right? So I actually tried this one. You could just sand a penny down so that you get the copper off of one side and the zinc on the other, and you can make a stack of these and make a battery. Alternatively, I guess Al links to one where you can do it with nickels, it looks like. So they're stacking up nickels and pennies to make a battery. Anyway, cool, fun science there. And then, of course, there's all the electrochemistry you can do with copper and zinc. Al seems fairly dismissive of dissolving the zinc in hydrochloric acid, but it's actually kind of fun. I totally recommend it. I've done this myself. Actually, if you're really careful about making the hole in the copper shell, you could actually dissolve the zinc out from inside and kind of make a hollow. You end up with just the copper shape of the penny. So you have kind of a hollow penny. It's kind of a fun trick. I haven't done some of the other ones. Apparently you could do all sorts of things with copper. Copper is one of those metals that likes to get electroplated by basically everything. And so pennies are a fantastic substrate for testing your funny electroplating magic on. That's the short version of the article. Check it out. There's a bunch of cool videos linked, and it'll give you a bunch of ideas that you could do with the pennies while you can still get 100 of them for the low price of $1.
I do recall that the 1982 pennies, I remember seeing a hack, and we might even have written it up. I don't know. I'll have to take a look for it. You can differentiate pre-1982 pennies from current bill because they weigh slightly different. The density of the copper and, a full slug copper versus zinc and copper clad is different. So the weight you can use as a kind of differentiation, gravimetric differentiation. If you build a rig that kind of moves pennies through like a circular thing with a penny-sized hole in it and move that over a weighted trap door, you can sort the 1982 pennies from everything else. And if you did that, you'd have a whole bunch of pure copper. More or less pure copper, which is far more valuable than the 1 cent face value of the coins. Now, as Al points out in the article, it is illegal to melt down coins for their metal. But is it illegal to electrolyze them? I wonder. That's not melting. I'm not a
I
lawyer.
don't think so. I think, yeah.
I think it's probably there's probably deface, destroy, spindle, mutilate, whatever.
Yeah,
But
yeah.
if all it says is melt, I'm just saying.
I mean, I think the laws exist to prevent counterfeiting and
Probably, yeah.
other obviously illegal activities. I think a little bit of messing around with copper is probably your right as an American citizen.
But still, there's ever since the mint stopped making them, which was only just recently. It was just a couple of days ago, I think. I mean, the penny is still legal tender. It's still out there. It's in circulation. There's billions of pennies out there.
Yeah, yeah. Who knows how many?
Yeah, most people have them in, drawers and, mayonnaise jars and things like that. To the point where stores are now asking for pennies. They want you to bring in pennies.
Oh,
and
God.
some are even going so far as to offering a premium on them. So, you give them, $1 worth of pennies, they'll give you $1.10 or something like that. I don't know.
Right.
So you could probably make more money with your pennies by just finding the stores that are desperate for them and bringing them in. But it's kind of neat to think that you could, if you really needed the copper, you could probably harvest it from the pennies. Okay, my pick this week for the Can't Miss articles completes the Al Williams sweep. Tech in Plain Sight pneumatic tubes. This isn't the series of tubes that makes up the internet. This is a completely different set of tubes that you may or may not have seen depending on your vintage and where you live and things like that. But pneumatic tubes used to be super prevalent in the United States and Europe and all over for any place where you needed to move documents around. That was the primary use case that I'm familiar with pneumatic tubes, although there's certainly other things that go in these systems. Basically, it's a air conveyor belt. So it's a tube that runs through a building or across a town or where you put a container in it. The container is roughly the size of the opening of the tube. You can put something like I said, like documents or x-rays, medical samples. That's something that Al kind of goes into some detail on in this story. And then through the power of either suction or compressed air, move those tubes along from one place to another. Hospitals had these all the time. I remember the hospital that I did my clinical rotations in the 1980s. There was a station right at the front desk of the x-ray department, and you could hear carriers coming through the tubes from a mile away, and you knew someone was sending a requisition for an x-ray down from the floors or from some department someplace, emergency room. This thing would come boom, 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 boom. It'd get louder as it got closer, and then finally, boom, it falls into the bin, and you open it up and find out what work you have to do. They were fantastic systems. They were much, much faster than walking things around by sneaker net. I still see them today in banks. All of our banks around here have drive-throughs that have pneumatic tube systems. There's one bank I know that's got 3 lanes in the drive-through, and each one of the stations has 2 or 3 tubes. So, it could service a huge number of cars at a time. The tellers are somewhere else inside that building. There's a little TV screen you can see. They can see you. You can see them. You talk to them, tell them what you want to do, put your coins in, put your bills in. Actually, I did make the mistake once of trying to get coins. I needed to get some change. So rolled coins came out in several lifts because they were like, we can't put them all in one. So they had to keep sending me carriers. Just a really, really cool system. I really like Al's Tech in Plain Sight series. It's been going really great. He's done a ton of different things. You should check out the series if you have any interest in all the stuff that's right before your eyes that you didn't know how cool it really was.
We're talking about this in our weekly meeting, and we were split kind of straight down the line, East Coast, West Coast, about who remembers these as being something that banks used to have back in the 70s and 80s. And something that banks still have today. It's really funny. I remember my bank when I was a kid had these, and it was so cool to put a check in there, and you put it in the little motorized thing and it goes down and then it goes swoop and it disappears. But they're so long gone in every bank I've been to, at least in Nashville. For me, it's a childhood memory, right, that was evoked by these. It's funny to hear you say that your bank has 3 channels of these things going in. The tech is fun. I totally agree. And it's amazing that they can go through those tubes. Every year, the German annual hacker convention, the Chaos Communication Congress, actually, maybe they didn't do it last time. I wonder where it went. would set up a tube system, a very similar thing, using big vacuum cleaners as the source of vacuum pressure and these kind of horrible rotating plywood discs to select which tube gets the thing. And instead of rigid tubes, they're using this kind of flexy, I don't know what it is. It must be a drain spout tube or something, but a really thin-walled, flexible drain spout tube, which has the advantage slash disadvantage that it's got those little corrugated waves in it to make it fold easier. And so when the shuttles go through, they go like that all the way along. And they get into the Congress Hall a few days before and will like run these up and over the ceiling tied to the rafters and stuff. And so when they go shooting by, it makes a tremendous racket and it's really absolutely hilarious. It's an absolutely absurd but very fun hacker project to make your own pneumatic tube system. So if you're bored on the weekend and you've got a lot of tubing.
In the comments for this one, Scuba Bear tells me about the bar called the Safe House in Milwaukee, which has a pneumatic tube system to deliver spy-teenies from the bar to the guests. A spy-themed bar, and they do a shaken not stirred martini, and they send it out in the tube.
Oh, how funny is that? That's brilliant.
Yeah. So there's a video. I'll put a link to it in the show notes, but that's pretty cool. Thanks to Scuba Bear for that.
Well, that does it for this week's Hackaday podcast. Thanks very much for listening. As always, you'll find the links in the show notes, and you can send us your tips at hackaday.com. And until next week,
keep on hacking.
I feel like I forgot to say something. Oh well.
Yeah.
All right, is it last? Yeah. That just came off the top of my head. Thank you.
Rightfully won a place in the National Geospatial Intelligence Hall of Fame, which now you know that exists.
The National Geospatial Intelligence Hall of Fame, naturally.
Okay, my next pick is casting metal tools with kitchen One more time.
All right, well, let's do some quick hacks without an intro because we have music for this.
Alrighty, first up for me in quick picks.
And what is it? Is it a system of tubes? It's a something of tubes.
Series of tubes.
Series of tubes.